Hello everyone, welcome to this video tutorial on independent sample t-test. Okay, so in this tutorial we will learn how independent sample t-test can be applied in SPSS. Okay, so before we actually start applying independent sample t-test in SPSS, let me explain you the concept and understand in what situation this independent sample t-test can be applied. Okay, so as far as the concept is concerned, simple. The independent sample test is a parametric test which is used to compare the mean between two groups, and these groups should be independent. That means whenever your objective of research is to compare the mean between two independent groups, then you can apply independent sample t-test. For example, you want to compare the academic performance in the form of CGPA. That means you want to compare the CGPA of a student of a class. That means you want to compare the CGPA of male and female student of a class. Okay, so there are two variables in this situation. One is your CGPA and second is the gender of student. So there are two variables. Okay, we want to compare the CGPA based on the gender. The gender is having two groups, one is male and second is female. Both are independent to each other. So whenever you are facing this kind of situation, you can apply independent sample t-test. Okay, as I have already explained, that we compare the mean of one variable based on the categories of other variable. That means in case of independent sample t-test, there are two variables. One is your test variable, second is your grouping variable. As you can see here, test variable or dependent variable, we call it, or grouping variable or independent variable. So you must remember that whatever is your test variable, that test variable should be scalar in nature. That means either it should be measured on interval scale or ratio scale. Okay, and whatever your grouping variable, it should be categorical. This variable should be categorical in nature. That means it should be measured on nominal scale, and category should be exactly two. Like in case of gender, categories are exactly two, male and female. Okay, so if we want to understand by the example is very simple. First variable we are having CGPA, which is a scalar variable, and we want to compare the CGPA based on one grouping variable, that is gender, and gender is having exactly two categories, male and female. So in this situation we can apply independent sample t-test. So before we move further, just understand the hypothesis also. So hypothesis of independent sample t-test are very simple. If you talk about null hypothesis, that is H0. Simple. Null says that both the mean are equal. There is no difference between the mean of both the groups. But the alternative hypothesis says there is a significant difference between the mean of two groups. As you can see here, mu1 is the mean of first group and mu2 is the mean of second group. So alternative hypothesis says both these means are not equal. That means there is a significant difference between these two mean. On the contrary, the null, which is the opposite of alternative, says that both the mean are equal. There is no difference between both the mean. So this hypothesis we can test with the help of independent sample t-test. Okay, so now we will see how this independent sample t-test can be applied in SPSS. So just wait, let me open this file for all of you. Okay, so this is the sample data which we will use for calculating independent sample t-test. Okay, so let me explain you this data set. So this is a simple data set of a company, employees of a company, which is having two variables. One is the gender of employees and second is how much bonus they are earning. So gender is having two categories, male and female. So now company wants to analyze whether the bonus earned by male candidates are equal to female, or is there any difference between the bonus earned by male and female employees. So this is a classic situation. You can easily apply independent sample t-test. Why? Because you have one variable which is your test variable, which is scalar in nature, that is bonus is a test variable and scalar in nature, and second is your grouping variable. That means on what basis we want to compare. So the basis of comparison is your gender, and gender is your categorical variable, and this is having exactly two category, male or female. Suppose in any case your categorical variable is having more than two category, like in this case gender is having only two category, male female, but if there is any categorical variable which is having more than two category, then what you will do, then in that case you will apply ANOVA in place of independent sample t-test. But this is an example of independent sample t-test. Let us focus on this only. Okay, so for applying independent sample t-test, it's very simple. Just go to analyze, click on compare mean, and then select independent sample t-test. Once you select independent sample t-test, this default dialog box will appear. So what you need to do, you need to transfer both the variable into test variable or grouping variable. You need to determine which variable is test variable. You need to determine which variable is grouping variable. So test variable is that variable which you want to compare. So here we want to compare bonus. So bonus is our test variable. We will transfer bonus into test variable, and we want to compare bonus based on gender of employee. So gender will be your grouping variable. So we will transfer gender into grouping variable. After transferring the grouping variable, you need to define the group. So for defining the group, just click on this define group. Okay, in define group, what you need to write, you need to write the code of both the group. That means whatever code you have used for gender. So in this situation, we have used 0 for male and 1 for female. So I'll write just 0, that is for male, and 1, that is for female, and then press continue, then press OK. So once you press OK, once you click on OK, result will appear. So these are the result of independent sample t-test. Now we will see how to interpret these results. Okay, so there are two tables. One is a simple descriptive table, which is just showing the mean of bonus of male as well as female. So what we can understand from this table is showing that this complete data set is having 2449 male and 2551 female. The mean bonus of a female member is 55.58 and mean member of female member is 54.51. Okay, mathematically if you see, we can clearly identify that mean of male is higher than mean of female, but statistically it is not so. It may be possible that this difference is because of by chance. There is no as such difference exists. This difference is just because we have taken a wrong sample, or there may be some sampling error. Because of that, by chance this difference is coming. This may not be a real difference. So how we will determine whether this difference is real or actually exists? We need to check the statistical significance of this difference. If this difference is statistically significant also, then we can conclude that male members are earning more bonus than female. Otherwise we cannot conclude. So for determining the significance, we need to calculate, or we need to apply independent sample t-test. So you can see in the table, in the result, second table is of independent sample t-test, second table is of independent sample t-test. So we will based on the value presented in this table, we will determine whether this difference is statistically significant or not. So before we actually apply the independent sample t-test, we need to understand one assumption of independent sample t-test, which says that variance should be equal across both the categories, So we need to check whether the variance is equal across the category or not. Now the question is how this can be checked. So for this purpose, we use Livein test of equality of variance. So Livein test of equality of variance is used for this purpose. Okay, so just wait. How this Livein test of equality of variance can be used? It is very simple. Okay, so as you can see in independent sample t-test, in first two rows this is the Livein test. So by default, along with independent sample t-test, Livein test is also applied automatically, so we need not to worry. Okay, what exactly this Livein test explain? This Livein test explain us whether the variance across the category are equal or not equal. Why we need to determine it? Because the procedure of calculating t statistics is different in case of equal variance, and it is different in case of non-equal variance, when your variance are not equal. So we need to understand, either we need to study first row or we need to study second row. First row result is in case of equal variance, and second row result are in case of non-equal variance. So first we need to determine whether variance are equal or not. So for this we will use this Livein test. So the simple concept of Livein test is, if the significance value of Livein test is, remember, if the significant value of Livein test is more than 0.05, then variance are equal, otherwise variance are not equal. Okay, so in this case value is 0.196, which is higher than 0.05, then we can say variance are equal. Otherwise, if this value will be like 0.03, then we will conclude that variance are not equal. But in this case value is 1.196, which is more than 0.05, so we can conclude that variance are equal. So now we are clear that we need to read this first column, the t-test result of first column, not the second column. So now we will read the result of first column. So t statistics is 0.682 with significance 0.495. Okay, to determine whether the difference between the groups are statistically significant or not, we need to check the significance of t statistics. So t statistics is 0.682 and significance of this t statistics is 0.495. Remember the thumb rule: if the value of significance, if the significance of t statistics is less than 0.05, then we say that difference between the groups are statistically significant. Then whatever difference is coming out, that difference is also statistically significant. But in case this p value, this significant value of t statistics is more than 0.05, then we will conclude that there is no significant difference in the both the groups, in both the groups. Okay, so in our situation, the value is coming out 0.495, which is way higher than 0.05. That means we can conclude whatever difference is coming in first table, that difference among male and female are not statistically significant. That means there is no difference between the bonus earned by male candidate and female candidate. So this is what the interpretation of independent sample t-test. Okay, you should also know one thing. I am saying, every time I am saying that we need to compare the significance from with 0.05. How this 0.05 value arise? Okay, so this 0.05 is arise out of the confidence level, because in social science we kept our confidence level at 95%. Okay, 95% means significance level is 1 minus your confidence level, that means 0.05. so this is how this 0.05 actually arrives. Okay, so this is all about independent sample t-test. So I hope this tutorial will help you to understand the concept, as well as you will able to apply independent sample t-test in SPSS. Okay. Thank you for watching.